Our next session is introducing the Artemis internal science team. If we can go to the next slide, please, Amanda. So some of these slides will look familiar. These are many of the things that we went over at the Artemis Town Hall at LPSC, but we were a little rushed for time there. So we're going to take a little more time today and actually introduce you to the team. A reminder that it's been 50 years since we've had humans doing science on the surface of another planetary body. And that Artemis and Apollo are different. They have different goals. The implementations are different, but certainly Artemis is building on Apollo, as well as all the constellation planning. You know, nothing gets wasted. It all comes around again. And so we have a lot behind us to work on, but there's some untread territory going forward, right? Clearly, the lunar science community is different. It's much bigger. And we've had 50 years to think about what it is we want to do on the moon. And so we are in a very different place than we were prior to Apollo. NASA is also different. During Apollo, there were very few lunar scientists at NASA. We now have a large cadre of very talented lunar scientists among our civil servants that we have come to rely on. And our approach here is actually pretty different in terms of the way that we are interacting with the commercial community as well as the international community. It's a much different environment than during Apollo. So we're going to introduce the science team today. The overall science team will be composed of a mixture of this internal science team as well as competed roles. And you've heard several of us talk about how the competed roles are going to work. And I just want to state again that this is all work in progress. We're building the railroad tracks as we're driving. But as always, my goal is to be as open and transparent with the community as possible as we work our way forward. Next slide. So again, this is the same slide I showed at LPSC. It shows us our sort of three legs of the Artemis science team. So today we're introducing this internal science team. These are NASA scientists that have already been working with Artemis, some of them for years. Up until now, they have largely been funded out of human exploration, but as of next fiscal year, they will be transitioning under SMD and being funded out of SMD. And these folks are all conflicted from competition. So if you have asked them to be on one of your teams and they politely turned you down, it's not you, it's me. I told them to do that, so don't take offense. Competitively selected geology team, as we talked about, there's a call placeholder that is out in Roses right now. We are working on that draft call and are going to try and get it out as soon as we can, but certainly within this Roses year. For a single 10-member team, so we'll select one 10-member team, including the PI. And then eventually we will also have a participating scientist program. That'll be closer to actual launch, probably a year or so before launch. We'll get those folks onboarded as well. And then there'll be competitively selected payload teams, as you heard Brad talk about. So we're putting out a call now. The placeholder is out for the Artemis 3-5 payloads, as well as for lunar terrain vehicles and for future missions. So collectively, this is what our science team will look like. Next slide. I just want to talk a little bit about what the role is of this internal team versus these competed teams we're bringing on board, right? So the internal team are there to make sure right now their most important job is to make sure that the architecture and the systems that are being developed can support the science that we want to do. So as I said, many of these guys have been working for years now. They're embedded on boards and teams and working groups across the agency. They're reviewing documents and making sure that everything that's being built can support the science that we want. They're also there to respond to rapid responses and requests and queries that we're getting from across the agency. And I just want to pause here and take a little tangent. I think it was last year at this meeting, I introduced the CARI team, the Contamination and Research Integrity team, which we had put together in order to specifically respond to these kinds of requests. If you can go to the next slide, please, Amanda. And now, as this internal team has come on board, we are disbanding that CARI team. But I just wanted to take a few minutes and publicly thank them for the huge amount of work that they did over the last year to make sure that all of our science needs could be met by the things that were being built. So you can see the kinds of requests that they got last year. A lot of requests from the tools teams for making sure that we're making tools out of the right things. requests from Curation about how to do cold curation conditioning, how to do contamination control, from camera specs to soft goods materials. These guys were sent all over the place to track things down and make sure that we're doing the absolute best we can for science. And so I just really want to thank them for the huge amount of work that they did last year. Next slide. Okay, so back from my little tangent. As we start to bring these competed teams on board, also this internal team will be the interface between NASA and those teams. They're going to lead the classroom, the field, and the ops training for the crew. They'll lead the operational training for the competed teams to make sure that you guys know what you're doing and come up to speed. And then as we move along through Artemis and these various sorties, they will provide sort of program level strategic planning to make sure that as we go from sortie to sortie, mission to mission, that there is continuity and that we are not missing things and have a plan for getting the most science. In contrast, the competed geology team will focus on their specific sortie. So on the Apollo Artemis 3 sortie, they will be developing the science objectives for that specific sortie, the field science goals, traverse planning, sampling strategies. They'll support the training as needed, again, being led by the internal team. They'll provide the real-time ops support, the preliminary exam of samples, and the geology report post-mission. Next slide. So again, I showed this slide at LPSC. Oh, nope, back. Too far. Again, I showed this slide at LPSC, and you got a quick peek at it, but we're going to actually go through today and allow each of these folks to introduce themselves. We're going to start out, you can see they're sort of grouped into separate teams there. We're going to start out with the training and ops folks. These guys have really been working hard for years now to build relationships within NASA, within the Flight Operations Directorate, to build up trust, and we would be nowhere without them. So with that, I'm going to turn it over to Cindy to introduce herself.
Hey. Hi, everybody. Thanks for having me. Can you hear me okay? Okay, great. Yes, I'm in Flagstaff with some colleagues here. We're getting ready to do some training. So I'm Cindy Evans. I'm at the Johnson Space Center, and I've been doing training for new astronaut classes since 2009. I've been the lead for the 2017 and the 2021 classes. And this is where we provide fundamental training for astronaut crews as they first come into NASA. We've also been training astronaut crews in Earth and planetary science for the International Space Station since 1989. I've been on lots of remote field and expeditionary trips. I think we have a mic somewhere. Okay. So anyhow, I'm really excited to be here in this role. I'm going to be the lead for the integrated geology training for the Artemis crews and the engineering flight operations staff, ensuring that the classroom and the field training, first of all, are integrated, they're funded, and they're in the training flow. Secondly, we are going to ensure that we're embedded with the EVA training team, together with the science, flight ops, and testing integration leads, otherwise known as Kelsey and Trevor. We work really, really closely together. We coordinate with the science team to implement the integrated training and testing requirements. Finally, I've been working the past couple of years helping to integrate the work of the multi-center Artemis science integration team that supports the human exploration activities, and we'll continue doing that. So I'm really excited to be part of Artemis. This is the first time in more than 50 years that geology and planetary science is in front and center for human exploration missions. So we get a chance to teach planetary exploration, to be able to build this collaborative culture of planetary exploration. Yes, I guess go next.
Hi, I'll take it next. For those who don't know me, I'm Kelsey Young. I'm a geologist at the NASA Goddard Space Flight Center. My background is in primarily field geology, specifically focusing on volcanology and impact cratering, and I've also got a lot of experience deploying in situ scientific field instruments in analog environments. I've also participated in quite a few NASA-funded analog missions over the years, including kind of the big integrated missions like DRATS and NEMO, and also some programs that I bet a lot of you are familiar with, like Survey and P-STAR-funded fieldwork. For the last 3 years or so, I've been one of the 2 science leads on the Exploration EVA operations team, which is preparing pre-mission and will execute lunar surface EVAs during our Artemis crewed surface missions. And so in that capacity, for the Artemis internal science team, I'll be serving as the science flight operations lead. I'll be the lead science representative to our mission control and specifically EVA flight control teams in MCC, both pre-mission, like I'm doing now with the Exploration EVA team, as well as during real-time operations. I'll also lead the integration of what you've heard Sarah and Brad mention today, which are the competitively selected geology and science instrument teams. And I'll lead that integration into the broader Artemis kind of EVA and mission control flight control teams. This will include a lot of different things. It will include kind of coming up with the architecture for how that integration will take place. So once we get you guys on board in our geology and science instrument teams, how will you interface with the rest of mission control? How will you interface with the crew through the EVA flight control team? We're well underway in determining that architecture now. It'll also include things like the communication structure. So how you'll be talking to each other, to me as the lead science representative, to the rest of the EVA flight control team, and then of course, how will those communications work all the way up to the crew on the lunar surface. As you heard Sarah and Cindy mention, we're also thinking a lot about training. So I'll lead the team training of the competitively selected geology and science instrument teams with my EVA flight control team colleagues. So we want to make sure that you guys are trained up and ready to participate in real-time mission operations and not just kind of the run up to the mission, like Sarah mentioned. We're also going to be looking at the infrastructure you need. So I'm hard at work figuring out the hardware and the software that you'll need, the physical infrastructure, where you'll sit, what you'll need when you're sitting on console, to make sure that when those selections are made, you guys are really able to jump right in and contribute. I'm also serving as the science team integration lead and the science operations lead for some Artemis mission simulations we have coming up to prepare us for lunar crewed surface missions. This includes missions like what you saw come out in the competitive call earlier this year for upcoming analog mission testing. And I'm also going to be interfacing quite a lot, of course, with Cindy and Trevor on this sort of training and ops team, but also with the rest of the Artemis internal science team that you'll hear talked about today to make sure that our spatial planning and infrastructure teams, as well as our software teams, are well integrated into our flight operations. And I'm really excited to be part of Artemis because I know I'm preaching to the choir, but our scientific exploration community has this incredible opportunity in front of us to really do some amazing lunar science and also to inspire the next generation. I think my favorite part about my job is working with this really integrated science, operations, engineering team, and we're really excited to continue to do so for Artemis and really excited to get the competitively selected geology and science payload teams on board. So thanks, and I'll turn it over to Trevor Graff.
All right, thanks, Kelsey. I'm Trevor Graff, and here with our USGS colleagues and Cindy, also in Flagstaff. But my home base is NASA Johnson Space Center, where I'm in the Astromaterials Research and Exploration Science Group. Some of you may know me from numerous years of Mars mission participation. I've had the fantastic opportunity to be part of MER missions, MSL, and build hardware for Mars 2020. So some experience there bringing over from the robotic missions over to the human world. Like Kelsey mentioned, and Cindy, a lot of field and expeditionary experience, and increasingly over the past 3 years at JSC, really getting hands-on hardware that we're developing for Artemis, suit experience, and trying to bring science to the forefront on some of these hardware decisions and requirements and operations as we move forward. Also bring some operational experience as an Army veteran for 16 years. The role that I play for this internal Artemis team is the EVA hardware and testing integration lead. So 2 big components there, right, is the hardware and the testing. The integration of both of those is really important. So my primary role is to interface as the science representative for some of the EVA hardware. And that includes, what may come immediately to mind, the geology tools, the equipment, the sample containment, working in tandem with the internal science team sample folks, but also the equipment transport and very importantly, the suit, and make sure it has the mobility and the types of interfaces we need to conduct science on the lunar surface. So I've been working that heavily over the past 3 years. You'll hear from Adam Nades on an EVA tools update later today, and other updates for some of the hardware that's coming online or that will be coming online. I also help facilitate development and coordination and the management of some of these EVA testing events. I have a few minutes later on today to talk more in depth on those, so stay tuned. But we're doing a ton of testing at JSC, and one of the most interesting and important things I think is it's a very well coordinated testing enterprise going forward that has science at the forefront, but hand in hand with our operations and our hardware folks. Like Kelsey, super excited about scientific discoveries that lay ahead with Artemis and how they'll inspire the next generation as Apollo really inspired me. So with that, back over to Sarah to talk a little bit about the sample.
Thanks, Trevor. Yep, our next group is the sample group folks. They are ready and helping us make sure that we are prepared to collect and to curate all of these samples and really maximize the science that we're going to be able to get out of those samples for this generation and the next. And I'm going to turn it over to Barb.
Hi, everyone. I'm Barbara Cohen. I'm a scientist at NASA Goddard Space Flight Center. My overarching career experience is really analyzing, collecting, and advocating for samples in the sample analysis community. Of course, the Apollo samples really revolutionized our idea of planetary science, how planets form and evolve. And they truly are the gift that keeps on giving. 40 years later, we were able to reanalyze those and find volatiles and open a whole new chapter in lunar history. So I'm excited to serve as the sample integrity lead. What that means is that I'll be helping make sure that the samples that we collect meet the goals for the whole Artemis program. And I'll be working with the computed teams, the instrument teams, and the geology teams to make sure that the samples that you want for your specific science goals, we're able to meet them within the programmatic constraints. So my expertise, as I said, is in sample analysis and collecting and executing missions as well that touch samples. So I've done a lot of laboratory work with noble gases, primarily petrology and geochemistry, working on meteorites, collecting them in Antarctica. I'm a principal investigator in the ANSCA program, opening up those fresh, pristine lunar samples from the Apollo 17 missions. I have been on CAPTEM, MWG, and most recently XMAG, advocating for sample analysis facilities, money, resources, time and effort in our community, and missions, future missions to collect those samples as well. I have a fair bit of robotic mission experience on the Mars rovers. You heard Trevor talk about some of those, lunar flashlight, and some of the CLIPS missions as well, having some payloads on those. And some desert rats and P-Star analog experience with various groups. So I'm pretty excited about advocating for these samples, making sure that they don't get shocked, they don't get heated, they don't get contaminated, that we develop operational scenarios to be able to collect them in a way that's appropriate for those samples, that we can store them properly, that we return them to Earth. And there are many possible ways to do these. So I'm looking forward to working with the whole competed team, all the instrument teams, and all the Artemis teams to be able to accomplish these things. I'm also working closely with the contamination control lead and the Artemis Curation office in this capacity. So we really do function as a team. Lots of things touch samples or may touch samples. So we all work together on different aspects of this. And so I will also be talking on the next slide about what the contamination control officer does. Can I have the next slide, please? Now, this position is coming up. It's not currently filled, so there will be an opportunity coming up to fill this position. the contamination control scientist, whereas the sample integrity lead, me, is more focused on the big picture, all the things that contribute to collecting and returning a sample. The contamination control scientist is really focused on the chemical contamination that goes into, or that can go into samples themselves and affect upcoming analyses. Not everything that touches or gets deposited on a sample is necessarily contamination, but some of it certainly is, and we want to understand that and control it to the best of our ability. So the contamination control scientist will be working to create a contamination control budget, a contamination budget for things like metals, organics, volatiles, all those things. They'll be working with a contamination control engineer who's embedded in the engineering side of things to really go out to the different teams, parcel out parts of the budget to those teams, and work with them to validate and verify their contributions to the contamination control budget. They'll also be working on a contamination knowledge program that is something like curating coupons of all the different materials, processes that we may use for all the different things that are sample intimate or sample adjacent. And they will be working with the whole sample team. So we're looking forward to seeing someone come into this role as well. And I'll turn it over to Julie, who is our Artemis Curation lead.
Thanks. Thanks, Barbara. Can you see and hear me? Okay, great. So my name is Julie Mitchell. I'm the Artemis Curation Lead. I'm in the Astromaterials Curation Office at the Johnson Space Center. One of the things that Barbara just mentioned was the ANCSA program, the Apollo Next Generation Sample Analysis Program. And I just want to touch on that just for a moment because it gets at the core of what curation is all about. And those samples, the ANCSA samples, were collected about 50 years ago during the Apollo missions, and yet we're still able to study those samples and learn about them 50 years later. And so that's what I want to see for Artemis. I want the Artemis samples that we collect to be able to be analyzed in another 50 years by folks who have instruments and state-of-the-art technologies that we haven't even thought of today. So in terms of my experience and expertise, in terms of what I've done for Artemis, so I started working Artemis pretty early on in terms of defining the Artemis contamination control requirements in collaboration with CAPTIM and the Lunar Exploration Analysis Group, League. And so we did some really groundbreaking work there a couple years ago. In addition, I've also drafted the initial concept of operations for sample return for Artemis with the Lunar Response Team at JSC and with our collaborators. I also work as the curator of ICES and organics. So my other job that you'll hear about a little bit later today is about studying volatile samples and understanding how we curate those samples, how we collect those samples and preserve them for the long term, given their unique temperature and storage constraints that we have to think about for those. I was also the project lead for the ANCSA cold curation facility. So some of you may know that a handful of the Apollo samples were curated at minus 20 degrees Celsius. And we recently opened those and sent some of those samples to science teams across the country. And so that was a huge success, and I was really happy to lead that part of the project. I was also a member of the Artemis Science Definition and Carry teams. So thanks, Sarah, for the shout out there. And I've also been the curation lead for the Caesar Comet Sample Return Mission Proposal for New Frontiers 4 and for New Frontiers 5. Prior to working on Artemis and in the curation office, my PhD is in remote sensing of the Moon and Mars. I also worked previously as a human spaceflight engineer. So I worked on technology development, requirements development, and flight and operations for life support systems, in particular water recycling technologies and hardware for ISS and shuttle. So my current role is Artemis Curation Lead. I plan and execute the Artemis Curation Facility. So this facility will store, it'll be where we store and process the samples and distribute them to the community. I'll also be defining contamination requirements for Artemis curation procedures and for the preliminary examination process. And so that'll be when we open the samples for the first time and we take a look at what we got and we make a nice catalog so that everyone in the community can request samples in the future and do their analyses on them. I'm also writing the Artemis Curation Plan, which kind of puts those first two bullets together and serve as an interface between the Astromaterials Curation Office and the Artemis Science Team. And I'm excited to be a part of Artemis for many reasons, but I'm in particular excited about having a permanent human presence on another planetary body, and I think the lunar South Pole is the perfect place to do that. One last note, I am really excited about all of this, but I am leaving the agency in about 3 weeks. And so I just wanted to say thanks to everyone who's been a part of this. And I'm super, super, super excited to see what this team and all of you accomplish over the coming years. And back to you, Sarah. Thanks.
Thank you, Julie, and you will be very much missed. But we do appreciate all of the work that you have put in up until now. It will not go unused and unwanted. Our next team is the planning and data team. We have just an overwhelming amount of data for the moon, which is fabulous, but it does take a team to make sure that we can bring some order to that chaos, and that is the team we have here. I'm going to turn it over to Sam.
All right, good afternoon. I'm happy to be here and I'm delighted to be here talking with all of you. I think most of you know me. I'm Sam Lawrence. I'm a planetary scientist at the Johnson Space Center. I've been an LRO science team member since 2007, and I'm an LROC co-investigator on the Lunar Process Orbiter Camera. I've been involved in many new frontiers and discovery proposals for science missions to the moon, most recently as the PI of the Inner Solar System Chronology mission, and relevant for this, extensive involvement in NASA strategic planning since 2005. I have been working on Artemis science integration, deeply embedded in the lunar architecture team for the what was then the HEOMD since August of 2018. And so my role here as part of the Artemis science team is to coordinate the integrated science campaign development efforts for Artemis surface missions. So uniquely, we have a lot of focus on Artemis 3, but it's kind of my job to help get that ball rolling and then move forward to Artemis 5 and 6 and try to be the person who is the beachhead for the next mission. So this includes surface science objectives planning and traceability to relevant foundational strategic documents like the Artemis 3 Science Definition Team Report and the League Lunar Exploration Roadmap. And I'm also here to coordinate lunar geospatial data analysis for a variety of use cases, including crew simulation and pre-mission flight hardware formulation and development. There's a lot of geospatial analysis that has to go into that. So, and this is also, I'm also the point of contact for various surface planning teams that are working on aspects of mission planning prior to launch. So we're at right now L minus 3. So there's a lot of activities that are picking up, and it's my job to help sort of be the interface between the competed science team and all of those internal NASA teams that are doing these sorts of activities to make sure that their plans are compatible with science objectives and use cases. This is tremendously exciting, and in many ways I've spent my entire life preparing for this moment in time. Our world is a stunning world full of wonder and opportunity, and this is a journey that began in the wind and the sand in 12 seconds of Kitty Hawk, and will continue with a thriving American presence on the surface of the moon, which is the first adventurous step towards creating a truly spacefaring civilization. And it's just so tremendously exciting to be here working for all of you. And with that, I'll turn it over to Dr. Petro.
All right, thanks so much, Sam. Appreciate the good words there. My name is Noah Petro at the NASA Goddard Space Flight Center, courtesy of my basement. Many of you remember, probably, hopefully, that I've been the LRO project scientist for several years, facilitating that mission as we've gone through now to our 5th extended science mission starting in October. In this role of LRO project scientist, I've had the great benefit to learn, digest the tremendous amount of data that LRO has contributed to our understanding of the moon. And as a result of that, I'm in the excellent opportunity to facilitate this digestion of LRO data amongst mission planners to help understand where and what we're going to be doing at the south pole of the moon. And so I really see what myself and Sam and Matt Miller, who you'll hear from in a minute, to do is to take this tremendous volume of data and make sure that it's, one, used properly, because there's a lot of things that people could do to LRO data that would lead to bad results. And two, work with basically the latest and greatest version of our data. And so what we're going to be doing is taking this massive volume of data and ensuring that's used properly, consistently across the entire Artemis enterprise. That means that the competed geology team, when they come on board and either develop products, will ensure that they're correct, but also used consistently throughout the program so that we're doing apples to apples comparisons and not introducing any data errors along the way. When we have surface deployed instruments, and so working with Renee and the instrument teams, knowing where on the surface those instruments are deployed, where we would like to deploy them, and then during operations, where things are on the surface, tracking where crew members are, where experiments are, so that we have a good understanding of the context for all of the measurements that we'll be making on the lunar surface. For me, this is an incredible opportunity to continue something that's deeply ingrained in my DNA. As many of you know, and as I tell people at every opportunity, my father helped build hardware for Apollo, and so for a second generation Petro to be involved in facilitating Artemis, to work with not just the selected teams, but the entire community come together for this incredible opportunity to learn about the moon, learn about the Earth-Moon environment, and extend our exploration of space to new frontiers is something I'm truly appreciative of having this role and working with our wonderful colleagues on this. One of the best colleagues I get to work with, and someone who I've learned more from in the last year and a half than just about anybody else, is Matt Miller, who's going to talk a bit about some of the software that we'll be using in this next era of lunar exploration. Matt.
Thanks, Noah. Hi, everyone. My name is Matthew Miller. I work as an exploration engineer at Johnson Space Center, and my background is in the fields of decision support system development and work domain development. I've had many fieldwork experiences, and I've worked closely with Flight Operations Directorate down at Johnson Space Center for ISS and Artemis training operations experiences. And I currently play a major role in the software product management space at Johnson Space Center and fielding software tools that meet the needs of users to execute missions. As on the internal science team, my primary role will be in the software systems lead, and I'll be the primary science interface for the software systems development and deployment to enable scientific operations on the lunar surface. As Noah mentioned, this vast amount of data is only going to be useful if we field it in ways and have it work with systems that meet the needs of our science and operations community. I'll be serving as the interface for the operations and data teams during all development and operational phases to make sure that these user needs align with the software capabilities that we deploy, so that you spend less time working against the tool and more time doing your job and being able to facilitate the needs of the mission. And the way we're going to be doing this too is I'll be helping facilitate the development, coordination, and management of the development of these tools throughout the integrated testing campaigns that we're going to be doing leading up to the actual mission, so that we can practice like we want to play and get all the gremlins out ahead of time, so that when we actually go to execute Artemis, that we'll be ready and our systems will be ready to help us. In terms of my excitement here, I think my fifth grade self would be incredibly stoked about where I'm at right now. And I'm really honored to be a part of this expedition to help explore the moon. So with that, last but not least, I'll pass it off to my colleague, Renee.
Hi, everyone.
Yes, that's right. Last but not least is our payload's team of one, who is in a league of her own. So we'll pass it off to Renee.
Oh, thanks, Sarah. Hi, everyone. My name is Renee Weber from Marshall Space Flight Center. My personal research background and expertise is in planetary geophysics and specifically in seismology. I have a lot of experience working with seismic data from the Apollo missions, from the instruments that were deployed as part of ALSEP, the Apollo Lunar Surface Experiments Package, from which we'll sort of delta for the upcoming deployed instruments call, which hopefully many of you out there will be participating in. In my role as chief scientist at Marshall Space Flight Center, I've also served as a sort of science advisor to the Human Landing System program, more recently within the newly established utilization payload team. So I'll be building from that role with the rest of the internal science team to serve as sort of a designated program interface for all SMD payloads and integrate across teams. So that includes the programs themselves, the HLS, Orion Gateway, the EVA office, the project offices, and the eventual instrument teams. And part of that role will include managing the rapidly evolving requirement space. So working to provide clarity both to SMD and to the payload teams on the program requirements and vehicle standards. So, sort of from the vehicle side, what the vehicle is capable of and what its requirements are. And then at the program level, working to ensure that science needs of the instruments and the teams are being understood and supported within the program. So sort of relaying information back and forth. I'm very excited to be a part of the Artemis program because I truly believe that we are paving the way for the next generation of lunar science. And, as one of the people that worked with data from deployed instruments during Apollo, I think I'll echo what Barbara said earlier about, the samples and the data that we gathered from the surface of the moon during Apollo really are the gift that keep on giving. And I'm extremely passionate about ensuring that the next 50 years of lunar scientists that come after us have the data and the samples that they need. So that's, I'm really looking forward to that. And I'll turn it back over to Sarah.
Thank you, Renee. And thank you to this entire team. Like, what an amazing team. Maybe you can take the slides down, Amanda, so we can get everybody back.